All right, 2.6, we're going to talk about rational functions. So rational functions are fractions. It's going to be when we have a polynomial on the top and a polynomial on the bottom. The domain of our rational function is going to be all real numbers except the x values that make the denominator 0. So it's all real numbers except, can't have 0 in the denominator of a fraction. So to find the domain, we just set the denominator not equal to 0. So in example 1, it says find the domain of the reciprocal function. So to find our domain, we just set the denominator not equal to 0. So in interval notation, how would we write all real numbers except 0? Awesome. Negative infinity to 0 and 0 to infinity. Now we're also going to talk about arrow notation. So arrow notation just kind of describes how our graph looks and like the arrows of the graph. So in this graph, we've got 4 arrows. We've got one pointing to the left here, down here, up here, and right here. Now we're going to describe these mathematically. So starting with the one that's pointing to the left over here. So we would say as x goes to, where's x pointing, in what direction? Negative infinity, perfect. Where is the y going? So we'd say f of x goes to, what's this approaching? 0. It's approaching 0. The y value is approaching 0. So we'd say as x goes to negative infinity, f of x goes to 0. Now to describe the one down below, we'd say as x goes to, where's x going here? X is going towards 0, but we have to be careful because notice how our x is going towards 0 down here and up here. So for the one at the bottom, we'd say as x goes to 0 in the negative direction. So we got to make sure we specify because we technically have 2 arrows that are going towards the direction of 0. So this one's coming from the negative direction. So as x goes to 0 in the negative direction, where's our y going? Negative infinity. It's pointing down, so it's going to negative infinity. Perfect. Next, let's do the one up top here, the one that's pointing up. Here we'd say as x goes to, where's x going to here? 0 from the positive direction now. So we'd say 0 with a little plus sign up top. Where is our y going? Positive infinity, perfect. And then lastly, we've got the one pointing to the right here. So we'd say as x goes to, where's our x going? Infinity. Where is our y going? Where's f of x going? To 0. Awesome. Great job. No. Next page talks about the answers for example 1. So exactly what we said, but it just puts it backwards, I think. I think it's easier to look at where your x is going first and then say where the y is going. This just kind of has it in reverse, but it's exactly what we said. But we said as x goes to 0 in the negative direction, we said f of x goes to negative infinity. So it just puts it in the opposite order. You can do it either way. Either way works. We're going to talk about vertical and horizontal asymptotes, not on this page, not on this one. We're going to go to on this page. So to find our vertical and horizontal asymptotes, our vertical asymptotes, we'd set the denominator equal to 0. So we have vertical asymptotes at the zeros of the denominator. But before we even do that, to find our vertical asymptotes, we have to make sure the numerator and the denominator have no common factors. If we have a common factor, that means that we have a whole. You can't have a vertical asymptote through a whole. Now to find the horizontal asymptote, there's a couple more directions that we have to follow. We're looking at the degrees of our numerator and the denominator. So in our numerator, when the degrees of the numerator is less than the degrees of the denominator, then our horizontal asymptote would be y equals 0. So if I had something like x over x cubed, I'd have a horizontal asymptote at y equals 0. When our degrees are the same on the numerator and the denominator, we look at the leading coefficient. So if I had 3x squared over 2x squared, when my degrees are the same, I'm looking at the leading coefficients. So my horizontal asymptote would be here, y equals 3 over 2. So that's when our degrees are the same. And then in part C, when the degrees in your numerator are greater than the degrees of your denominator, we have no horizontal asymptote. So if I had something like x cubed over x squared, we'd have no horizontal asymptote. So on Canvas, there's a cheat sheet. It's got everything that we're going to need for our rational functions. To find the domain, we set the denominator not equal to 0. Vertical asymptotes, we set the denominator equal to 0. So domain and vertical asymptotes kind of go hand in hand. These are going to be the same values. Horizontal asymptotes, we look at the degree. And so degrees are the same, then we're looking at the leading coefficients. Slant asymptote, we're going to talk about in a couple slides. We use long division to find a slant asymptote. To find the y-intercept, you can plug in 0 for x. To find the x-intercept, you're plugging in 0 into y, but an easier way to find that would be just set the numerator equal to 0. And then to find the wholes, you factor the numerator and the denominator, and then cross out the common factors. So I think the cheat sheet's super helpful to use for the homework. You cannot use it for the test, so just make sure you have all of these in your brain for the test. Let's look at example 2. So we want to find all the vertical and horizontal asymptotes of the graph of each rational function. So first thing we want to ask ourselves, is there any common factors in the numerator and the denominator? Because that will affect our vertical asymptotes. Here, I can't factor my numerator, but can I factor the denominator? What does it factor into? X plus 1, x minus 1. Do we have any common factors? No. We would need an x plus 1 or x minus 1 on the top to cancel something out. So we don't have any common factors. So let's go ahead and find our vertical asymptote and horizontal asymptote. What do we do to find our vertical asymptote? Set the denominator equal to 0. So when you set the denominator equal to 0, if it's something that can be factored, you'd factor it to solve. So we already did the first step. So factoring to find your common factors is helpful to find your wholes in the beginning. You definitely want to do that, but it's not a waste of time even if you have no wholes, because you're going to use the factored form anyways to find when it equals 0. So set them equal to 0. We get x equals -1 and x equals +1. So we have a vertical asymptote at x equals -1 and x equals +1. Vertical asymptotes are a vertical line. They're like a dotted line on your graph. You need the x equals. It's not just a number. You need the x equals there. Next, let's find our horizontal asymptotes. Horizontal asymptotes, we're looking at the degrees. When our degrees are the same, then what do we look at? The leading coefficients. So our leading coefficients would be 2 over 1. So what's our horizontal asymptote? Y equals 2. Again, it's a horizontal line, so you need the y equals. And then just for fun, let's find our domain too. So domain goes hand in hand with the vertical asymptotes. How would we write all real numbers except -1 and 1 in interval notation? All right, let's do B. First thing we want to ask ourselves, is there any common factors? So we got to factor the numerator and the denominator. What are two factors of -2 that add to 1? 2 and -1, perfect. So we've got x plus 2 and x minus 1 on top. On the bottom, what are two factors of -6 that add to -1? -3 and 2. So x minus 3 and x plus 2. Do we have any common factors? X plus 2 is a common factor. So we've got a hole at, we'd set this equal to 0. So what would be the x value that we have a hole at? -2. Perfect. We've got a hole at the x value, -2. To find the y value where we have the hole, we're going to take -2 and plug it into our simplified version of it. If I plugged -2 into the non-simplified version, we'd end up getting 0 on the top and 0 in the denominator. So that's not going to give us any information. Good morning. You can just throw your pass away. Throw it away. Thank you. So we're going to plug it into the simplified version. So we've got x minus 1 on top and x minus 3 on the bottom. So we plug in -2, we get -3 over -5. So our y value of our hole would be 3 over 5. So to find the y value, just plug in your x into the simplified version. So that's for the hole. Let's find now our vertical asymptote and horizontal asymptote and the domain. How do we find the vertical asymptote? Set the denominator equal to 0. So you can set the original denominator equal to 0. We already factored, so we did the first step. So we have x is equal to 3 and x is equal to -2, but you can't have a vertical asymptote through the hole. We've got a hole at -2. We're not going to have a vertical asymptote through the hole. So our only vertical asymptote would be in the simplified version. We set the denominator equal to 0. So we've got x equals 3. So you cannot have a vertical asymptote through the hole. We had a hole at -2, so it's not a vertical asymptote. Now for our horizontal asymptote, what do we look at? The degrees. So our degree of our numerator and the denominator, when they're the same, then what do we look at? The coefficients. So what would our coefficients be here? 1. So how would we write our horizontal asymptote? Y equals 1. Perfect. Now for our domain. What would our domain be? It's all real numbers except what? Be careful. What else is not included? The hole. So your domain has to include whatever your vertical asymptote is and the hole. So the domain, you'd want to set your original denominator not equal to 0. So it's got to include both of these numbers. Because if I had -2, that gives me undefined in my fraction. So that's not going to be part of our domain too. So our domain, we'd say from -infinity to -2, -2 to 3, and then 3 to infinity. Next, we're going to be graphing our rational functions. So we want to find everything. We want to find our vertical asymptote, horizontal asymptote, if we have holes. We want to find our x-intercepts, y-intercepts, and just put it all on a graph. So it's a lot of stuff, but just a lot of little things. So every step that we find, it helps us build an idea of what our graph looks like. This says step 1, determine whether your graph has symmetry. This is a helpful hint. Most of the time, it's not going to have symmetry. Occasionally, you'll see some y-axis symmetry. So if you plug in a negative into the x and you end up with the original, you have y-axis symmetry. So that means whatever you have on the left side, you've got the same thing on the right side. Could look like a parabola in the middle. But it's going to be a rational function. So it'll be the same mirror image on the left and right if you have y-axis symmetry. So it's kind of helpful to look for it, but you can always just plug in numbers to get an idea of what your graph looks like. We also want to find, again, everything. Y-intercept, x-intercept, vertical asymptote, horizontal asymptote to get an idea of what our graph looks like. And then we'd plot some points. So in example 3, we're going to graph. So we're going to find everything. We'll find our vertical asymptote, horizontal asymptote. We'll find our domain, x-intercept, y-intercept, and if we have any holes. So first thing we want to do is see if we have any common factors in the numerator and the denominator. Do we? Nope. Can't factor the numerator, and our denominator is already factored, x minus 2. We don't have any common factors. How would we find the vertical asymptote? Set the denominator equal to 0. So what would our vertical asymptote be? X equals 2. Awesome. And since we have no common factors, we can say no holes. Vertical asymptote goes hand in hand with domain, so let's find that one next. What would our domain be? Negative infinity to 2 and 2 to infinity. Perfect. And I'm going to go ahead and graph that too. I've got a vertical asymptote through 2. So I'm going to put a dotted line through 2. Now let's find our horizontal asymptote. What do we look at for horizontal asymptote? The degrees. My degree on top is the same on the bottom. So then what are we looking at? The leading coefficient. So what would my horizontal asymptote be? Y equals 5. Perfect. So we're going to put a dotted line through 5. A horizontal line through 5. Next, for our x-intercept, what do we do to find our x-intercept? Set the numerator equal to 0. Perfect. So we've got 5x equals 0. Divide both sides by 5. What does x equal? 0. So how would we write that as an x-intercept? 0, 0. So I can put that point on my graph. Next, for our y-intercept, what do we do to find a y-intercept? Plug in 0 into the x. We've got 5 times 0 over 0 minus 2. So that'd be 0 over negative 2, which is 0. So my y-intercept would be the same thing, 0, 0. So it's the same point. Now let's graph. So we've got one point, which is super helpful. You can never cross a vertical asymptote. Sometimes near the middle of your graph, you can cross a horizontal asymptote, but you can never cross a vertical one. So we kind of have an idea that our graph's going to be on that left bottom quadrant. We want to figure out what the right side's going to do too. So let's plug in a few points to get an idea. What would be a good number to plug in on the left side to get an idea of how our graph looks on the left? Sure, negative 2. Anything on the left except 0, because we already have a point at 0. So if you plug in 0, you're going to end up getting 0. So you could plug in something like negative 1, negative 2, negative 3, negative 4, whatever you want to get an idea of how your graph looks. So let's plug in negative 2. So we've got 5 times negative 2 over negative 2 minus 2. This would be negative 10 over negative 4, which simplifies to 5 over 2. So I plugged in negative 2 and got 2.5. And when you're plugging in values here, you're starting off with a fraction. So most of the time when you plug in a number, you're going to end up with a fraction. I think it's helpful, turn it into a decimal to give you an idea of where your graph is. As long as you can figure out what whole number you're closest to, it gives you a good point on your graph. So we're going to go to the left to negative 2 and up 2.5. So now when we draw our graph, we're going to kind of hug the corner like a boomerang. And as we go out towards infinity or negative infinity here, our graph's going to get close to the asymptote. So our graph will look like this. Yes. If we get tested, the test would probably say plug in like 3 additional points. So just for the sake of time with the notes, because we've got a few more examples to do, I'm just going to plug in 1. But plugging in like a number in between your x-intercept, y-intercept, and your asymptotes is kind of helpful. So you can plug in as many points as you want to get a more exact graph, but they'd probably say like plug in 3 points. Now let's figure out what the right side of our vertical asymptote, what our graph's going to look like over here. What's a good number to plug in on the right side? 3 works. You can plug in 3, 4, 5, anything greater than 2. So we can plug in 3. So 5 times 3 over 3 minus 2. So this would be 15 over 1. So we plugged in 3 and got 15. So it's going to be a little bit off of our graph up here, but that's okay. I'd say let's plug in another number just to get a better idea, but it does help us that we know that we're above the graph. Because your graph could have looked down here, it could be up here. So you do want to figure out, are you going to be above your horizontal asymptote or below? Let's plug in one other number. So I'd say like 4 or 5. Let's plug in 5. So we've got 5 times 5 over 5 minus 2. So 25 over 3. 3 goes into 25 8 times with 1 left over. You can call it like 8.2, 8.3-ish. Again, when you're graphing, there's really not a difference between 8.2, 8.3, 8.4, 8.5. It's all going to kind of look the same. So as long as you're close to your whole number, we know that we are going to be a little bit above 8 for a point. So I plugged in 5 and got, I'll call it 8.3-ish. So I'm going to go to the right 5 and up 8-ish. That gives us a little bit better idea of how our graph looks. So I know my graph's going to hug the corner, and as we go out to infinity, it's going to get closer and closer to my asymptotes. So it'll look like this. With example 4, it may be helpful if you don't have to actually like work it out, but think about if I plugged in a negative into the x and I square it, it's going to end up being the same thing. It'll end up being positive. Same thing with the denominator. If I plug into a negative into the x, when you square it, it's going to be the same number. So here we have an even function, so we're going to have symmetry over the y-axis. So I'll say y-axis symmetry. So that helps us when we're plugging in points. We know whatever we have on the right side of our graph, we're going to have the same thing on the left side. So next, we could possibly have a slant asymptote. So a slant asymptote's not a vertical or horizontal line. It's going to be a slanted line, but it's going to be a line in the form of y equals mx plus b. So it's going to be a line. We could possibly have a slant asymptote when the degree of the numerator is 1 more than the degree of the denominator. If your degree of the numerator is 2 more than the degree of your denominator, you're not going to have a slant asymptote. So it only happens when your degree of the numerator is 1 degree more than the denominator. And when we have a slant asymptote, this means that we have no horizontal asymptote. Because when your degree of the numerator is more than the degree of the denominator, you have no horizontal asymptote. And the equation of your slant asymptote can be found by division. So we're either going to be doing long division or synthetic division. It depends on what we're being asked to divide into it, what our dividend is. But for a slant asymptote, we only include like the whole number part. Our slant asymptote is going to be in the form of y equals mx plus b. So we only care about the x and the constant. The remainder, we're going to get rid of it. We drop the remainder. So you'll end up with a remainder. It's not going to divide in evenly, but you just drop it. Get rid of it. Doesn't matter what your remainder is. So let's look at example 5. So it says identify the asymptotes and graph the function. First thing we want to do is see if we have any common factors. So if we have a common factor, that means that we have a hole there. So how would I factor the numerator? Take out an x, and we're left with x minus 1. Our denominator is already factored, so we've got x plus 1. Do I have any common factors in the numerator and the denominator? No. So no holes. Next, let's find our, vertical asymptote, horizontal asymptote, and slant asymptote. What would our vertical asymptote be? What do we do to find the vertical asymptote? Set the denominator equal to 0. So we've got x equals negative 1. We can graph that. So our vertical asymptote goes through negative 1. Next, what would our horizontal asymptote be? So if our degree of the numerator is higher than the degree of the denominator, what's our horizontal asymptote? None. Our degree of our numerator is 1 degree higher than the degree of our denominator, so we've got a slant asymptote. How do we find the slant asymptote? Long division. Here, since our denominator is x plus 1, you can do synthetic division. I'm going to do long division just so we can practice, because it's not always going to be the case where you can use synthetic division. So inside the box, I've got x squared minus x. I'm going to say plus 0 to act as my placeholder there, because I need a constant. And then outside, we've got x plus 1. So step 1, we divide. X squared divided by x is x. Then we multiply. Get x squared plus x. Change the signs and combine. So this turns into negative 2x. What's negative 2x divided by x? Negative 2. You can stop here. Once you get your x and your constant, this is all you need for your slant asymptote. You can keep going if you want, but you don't need to. It's just a waste of time. What would our slant asymptote be? Awesome. Y equals x minus 2. It's a line, so you need your y equals. Now let's graph our slant asymptote. I know that you guys know how to graph a line. What would our slope be? 1. And what's our y-intercept? Negative 2. So let's start with our y-intercept. I'm going to put a point there at negative 2. And then the slope of 1, we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. You can put as many points as you want. I like to put a couple just because it keeps my line straight. Put a few points, and then you can draw your asymptote through your points. Now we'll graph this whole thing. Let's find our y-intercept, x-intercept, and we'll plug in a few more points to get an idea of where our graph is. How do we find the y-intercept? Plug in 0 into the x. So that would be 0 squared minus 0 over 0 plus 1. So 0 over 1. So what would our y-intercept be? 0, 0. So I've got a point at 0, 0. How do we find our x-intercept? Set the numerator equal to 0. So I'm going to set the already factored one equal to 0. So we've got x equals 0 and x equals 1, because I just set both of my factors here equal to 0. So one x-intercept would be 0, 0. The other one would be 1, 0. Just go to the right 1, stay at 0. Yes?
So for y-intercept, it's like all of the x equals 0, and then for x-intercept is only the numerator?
So for the y-intercept, you're plugging in 0 into the x's. For the x-intercept, you just need to set the numerator equal to 0. Because you're technically plugging 0 into the y here, but you just need your numerator to be equal to 0 for your whole fraction to be equal to 0. So kind of like a shortcut would just be setting the numerator equal to 0. All right, so we've got a couple points in that upper right-hand quadrant up here, so I can draw my graph. That gives me a good idea of what my graph looks like. I'm going to hug the corner and get close to the asymptotes. I'm going to cross the axis at my intercepts, so it'll kind of look like this. So we know what our graph on our right side of the vertical asymptote looks like. Is it possible that I could have a piece of the graph down here too? What do we think? Do we have a piece of the graph down here? No. Why not? What do we think? Would it be a function if we had a piece of a graph down here? Does it pass the vertical line test? No. So it would not be a function. So we're just looking for what our graph does over here. You also, if you plugged in something like 3, you'd end up probably getting something close to 2. You're not going to get another point down here also. So we took care of the right side. Let's do the left side. What number should we plug in on the left? We can do -2. That works. Anything that's less than -1. So let's plug in -2. So -2 squared minus -2 over -2 plus 1. So this would be 4 plus 2 over -1. So we get -6. So we plugged in -2 and got -6. So I'm going to go to my graph, go to the left to -2 and down -6. So I've got a point there. Just to be even more sure where my graph is going to be, let's plug in another number. I'm going to say let's do like -4. Yes?
Can you cross a slant asymptote?
You can cross the slant asymptote. You can. Yeah. But as you get closer to infinity, so as you go out, you're not going to cross it. So it is possible to cross it close to 0. It does happen, but usually you won't. So let's plug in, I said 4, so -4. So -4 squared minus -4 over -4 plus 1. So this would be 16 plus 4 would be 20 over -3. 20 goes into -3. I mean, -3 goes into 20 6 times. Almost 7, so we can say 6.6. So I plugged in -4 and got -6.6-ish. So we'll go to the left to -4, go down 6.6-ish. So that gives us a little bit better idea of how our graph looks. We're going to hug this corner in here. As we get closer to infinity, our graph's going to get closer to the asymptotes. So here, let's find the horizontal, vertical asymptote, slant asymptote, and holes and graph. Yay. So I'm going to say vertical asymptote, horizontal asymptote, slant asymptote, holes. We'll find the domain too, and our x and y intercepts. Well, before we start, let's factor our numerator and the denominator. We got to see if we have any common factors. So starting with our numerator, what are 2 factors of 4 that add to -5? -4 and 1. So we've got x minus 4 and x plus 1. -1, yes. X minus 1. How would we factor our denominator? X plus 2, x minus 2. Do we have any common factors? Nope, so we're going to say no holes. Next, how do we find our vertical asymptote? Set the denominator equal to 0. So you can either set your original one equal to 0 or the factored one equal to 0. I'm going to set the factored one equal to 0 because we kind of did the first step for us already. So we've got x equals -2 and x equals +2. So I've got two vertical asymptotes here, x equals -2 and +2. So I'm going to put a vertical asymptote through -2 and +2. What would our horizontal asymptote be here? Y equals 1. Awesome. Our numerator and denominator have the same degrees, so we look at the coefficient, so y equals 1. Do we have a slant asymptote? Nope. If you have a horizontal asymptote, you're not going to have a slant asymptote. What would our domain be in interval notation? Awesome. -∞, -2, -2 to 2, and 2 to infinity. Perfect. Next, how do we find the x-intercept? Set the numerator equal to 0. So I already factored the numerator. I did the first step for us. Set it equal to 0. We get x equals 4 and 1. So when I write that as an x-intercept, I've got 4, 0 and 1, 0. So I'm going to put a point at 4 and 1. Next, let's find our y-intercept. How do we find the y-intercept? Plug 0 into the x's. So I've got 0 squared minus 5 times 0 plus 4 over 0 squared minus 4. So zeros just go away. We've got 4 over -4, which would be -1. So my y-intercept would be 0, -1. Any questions here so far? Let's plug in some numbers to see what our graph looks like. Let's work with the left side first. Let's figure out our left side of our vertical asymptote. What should we plug in? Anything less than -2. So you can plug in -3. You can plug it into the original function, or you can plug it into factored form. Either way, doesn't matter. Plug in whichever one you like better. I'll plug it into the original. So let's plug in -3. Got -3 squared minus 5 times -3 plus 4. And then -3 squared minus 4. So 9 plus 15 plus 4 over 9 minus 4. This would be 24 plus 4, so 28 over 5. So we've got -3, 5 goes into 28 5 times with 3 left over. So I would say 5.6-ish. Again, there's really not much of a difference between 5.6, 5.5, anything like that. Just we're in between 5 and 6. As long as you're in between the two whole numbers that your fraction's close to, that will help. So we're going to go to the left to -3 and up 5.6-ish. I would plug in another number on the left side just to be super sure, but I know that my graph is going to hug this corner, and as we get close to infinity, or as we get close to our as we go out to infinity, we're going to get close to the asymptotes. The middle is going to be a little bit funky. Let's look at our points that we have so far in the middle. It's not. Is this an even function? If I plug in a negative into my x's, am I going to end up with the same thing? No. We do have the x squareds, but we have that x in the middle that's going to throw it off. So it's not an even function. We're not going to be symmetrical about our y-axis here. We also know that because I've got a point over here, and I don't have that same exact point over here. So in the middle, it could be a parabola. It could be more like an x cubed graph. We know that it's going to end up going this way because I don't go back and cross the x-axis because I only have this as my x-intercept. I don't cross it again. So our graph is going to go down to infinity over here. So I know that my graph looks like this. But the right side, we could either go up this way or we could go down this way. So this one's a little bit tricky because to figure out which way we go, we need to plug in a number in between 1 and 2. 0.5, perfect. Let's plug in, yeah, 1.5. 1.5. You're right. You can either plug in 1.5 into the original or into the factored version. I think maybe plugging in 1.5 would be a little bit easier into the factored version of it, because that way we're only going to have to multiply a decimal on the top and on the bottom. So 1.5 minus 4 would be what? Negative 2.5, perfect. And then 1.5 minus 1 would be 0.5 over 1.5 plus 2. I did not leave myself much room here to work, but I'll do it down here. 1.5 plus 2 and 1.5 minus 2. So 1.5 plus 2 would be 3.5. 1.5 minus 2 would be negative 0.5. We can do a little bit of simplifying, so we don't even have to multiply. If I've got a 0.5 on the top and a 0.5 on the bottom, we can just cross them off. But we do have a negative, so that negative's got to stay. So this would be negative 2.5 over negative 3.5, which would be, I'll multiply the top and the bottom by 10 to make it a little bit easier for us to see. And my pencil just died. So we've got 25 over 35. Divide them both by 5. This would be 5 over 7. So that helps us a little bit. We plugged in 1.5 and got 5 over 7, which is going to be less than 1, or greater than 0. So going to our graph, our point's going to be about here. Is it possible that I can go up here and then cross back the x-axis down here again? No, we don't have another x-intercept, so we know that our graph is going to go this way. Any questions here? The right side of our graph, you can plug in another number, but it's going to hug this corner. So I'm going to draw my graph this way. Any questions here?